Hi, everybody. I'm Giorgio, your host for today, and welcome to this new talk of the Italian Spring Boot community. We will talk about event sourcing with an international speaker. He is a lead developer of Axon Framework. Welcome, Steven van Beelen.
Thank you, Giorgio. I hope I'm audible at the moment. And if so, then, thanks for the great introduction. A lovely sound quality up front, by the way. I was kind of blown away by the music. So, what's going to happen? Seems like a rough introduction for the likes of me, but thanks regardless. Cool. Is my, sorry, go on.
How it's going? You are in Europe?
Yeah. Yes. I'm situated in the Netherlands, close to the city called Utrecht. And Utrecht is in turn relatively close to Amsterdam, which people do know. So,
Okay. And so tell me a little bit about you, Axon Framework, and then we can start with your talk.
sure thing. So I'm Steven. Just call me Steven. It's easy. The surname is a bit complex outside of the Netherlands, so I tend not to use it. I work for Exonic. I have been working for Exonic since the start of the company, which has been 2017. And even before that, I was already working with Axon Framework. I've used it at a bunch of clients for my previous company. And in the flow of that, once getting more acquainted with the tools, our CTO back then and current CTO as well, Allard, asked if I wanted to join a startup around the subject of CQRS, DDD, and event sourcing. So I figured, why not? This is awesome. I really liked it. And that eventually led me the title of lead developer, meaning I manage Axon Framework and a bunch of the extensions. So you might be able to chat with me on one of our repositories or on the forum. So what Axon Framework is a Java-based open source framework, providing you building blocks to do domain-driven design, command query responsibility separation, and event sourcing. And at the core of that all, doing that through messaging. So having distinct types of messages to enable you to do that. And we believe that that's a way to make a very nice, well-structured applications. And it integrates pretty well with Spring because our founder used to work with the people that founded Spring as well in the past. So it was a very natural fit to make the framework fit with that as well. Axon Framework has been 12 years old already, by the way, if you want to have a grasp. So that's why it's a bit near. It's more hip for the last couple of years, though. So, yeah.
Great. So I think we can start. I
Sure thing.
share your screen and I give you the stage. Enjoy.
Thank you, Giorgio. Right. So, hi, everybody. This is my talk about event sourcing with RSocket with the tagline, and now we are talking. I really like that tagline because it really is a notion of the way we're going to talk with our application. So, what I have prepared is firstly a couple of assumptions. So, you might have already seen this talk at Spring One. I did it last year, and it was somewhat of a lightning talk back then, so I had to be extremely fast. I was very happy I made it, but yeah, this somewhat dictates the flow. This doesn't mean we can steer away a little bit from it. I have more time here, so thank you for that, Giorgio, giving me a bit more relaxed vibe. That's good. So if you have any questions on more specific topics that I might glance over because I am making assumptions, feel free to type your request in the chat. You can also do that in Italian or in another language. I do speak English. I speak Dutch as well, although I assume there are no Dutchies in here. Just type your question in the language you're proficient with, and we'll try our best to give you an answer. And I might just show different portions from what I would normally do in this presentation. So regardless, I'm making a couple of assumptions, as pointed out, because this is used to be a lightning talk. And assumptions revolve around the paradigms we're going to use. So I just pointed out that Axon Framework helps you to do DDD, CQRS, and event sourcing. And in all honesty, I could fill an hour for each of these topics if you want to, because there's so much to it. However, for now, if we're talking about domain-driven design, The core of it all is thinking that we use a domain model or several domain models to describe our application. And such a domain model, in turn, consists out of DDD building blocks like aggregates and entities and value objects. So definitely the term aggregate is something you will be seeing more frequent, which really comes from the perspective of how it is described in DDD. Second assumption is CQRS, or Command Query Responsibility Separation. It means, or it is an architectural pattern, meaning that you're going to separate the concern of dealing with commands from the concern of dealing with queries, where a command is the desire to do some change, and a query is the request for information. At the core, CQRS only describes itself as a distinction in APIs, but we're going to combine that with domain-driven design. So we're going to do DDD and CQRS, meaning we don't have a single type of domain model. No, we have a specific command model and a specific query model, where the command model is focused on handling the commands, executing those tasks, and the query model is focused on having the information, providing it as required. In the mix of that, we're going to combine it with event sourcing. So what we're doing with CQRS is we need to have a means to synchronize the changes, the decisions, or the executions made on the command side into the query side. This is where an event-driven architecture fits perfectly. So the command side makes a decision and publishes an event that will eventually be handled by the query side to update the query model. What we do with event sourcing is that we're going to source every type of model we have in that system that forms the basis based on events. So not just streaming the events to the query side, but also recreating the command side based on the events or the decisions it has made. Fourthly, we have one I'm pretty certain you're familiar with, and that's the assumption that you know about microservices. Really talking about separate applications or services or modules that are going to talk with one another. And it's specifically that talking bit, so what I also had in the tagline, that I want to focus on, because this is where the idea of RSocket comes in. So what I have is firstly the different types of messages. So I pointed out that events are used to synchronize the decisions made from the command side to the query side. But I want to focus on it because there's a different way of using these and how they are routed. When you're talking about an event, you're talking about something relevant that has happened inside your domain. What's important here is that it's past tense. It has happened. It is from the past. And because it has happened, it is not something you can change. It is a fact. It's history. In real life, we can't change history either, even though we might want to, but you need to deal with the fact that that has happened. This is why, because it is a fact that is, well, a fact, everybody can read it. It is really a broadcast type of mechanism to dispatch events. Furthermore, it's a consumer subscriber type of thing, and the consumer handles the event, but needs to deal with what it is at that moment in time. It can't go back to the original publisher of that event saying it's not happy with it, because of the notion of it being from the past. You don't know if you're handling something at that moment in time or something from a couple of seconds ago, a couple of minutes ago. It's just the messaging paradigm around events is you deal with it. There's no way to return a result if you're not happy with it. With just events, we can make an event-driven architecture to communicate between our microservices or our services or our modules. But if we just use events, we'd just be talking in past tense, always saying, I want you to have done this, I want you to have done that. And that's not the overly ideal way of communicating. We wouldn't do that in real life either. So having different types of messages is going to benefit us in designing our applications, in designing our API. So this is where two types of messages come in, having commands and queries, really mirroring the idea of doing DDD, CQRS, and event sourcing together by having not only those command models, not only those APIs for commands and queries, but actual messages that are flowing to those components. A command is different from an event in the fact that it is routed to a single handler. This is because something is in charge of deciding whether that change can happen. Typically, this is a specific instance of the command model. It handles the command, validates its state, and publishes an event as a result. Now, from command handling, a single handler, there is a notion of returning a result back, but just in OK or in not OK. You wouldn't return the adjusted state because that's what the queries are intended for. You wouldn't do that with these commands. We want to keep them as simple as possible. The desire to do something, the expression of intent to perform some change, and just an OK or not OK. What's important with command routing is we want that to happen consistently. So this is where you can use consistent hashing based on the value in the message to always route the command to the same service or the same service instance, just to be certain that we're not duplicating the handling of a model in two locations. Queries are also different when it comes to routing because they don't necessarily go to a single handler. There might be several handlers that can answer a query. So this is where load balancing is a much more reasonable solution to take into account when to decide where to route the query to. But we're not just dispatching a query to a single source. I might also be dispatching a query to a group of things. I actually just did that. I asked everybody of you to just answer in your own language. I'm still waiting for the responses. Likely I'm not getting a response. That's fine. But I'm just differently using a query. So when you're actually using queries, you're not only going to do point to point, you can also scatter out and gather the results. And very importantly, there definitely is a result coming back from a query message. You want to get a query response because without it, well, the request for information wouldn't work. With that in place, we can make a form of a diagram. So what we have in here is a very basic application with separate components inside, dedicated components that deal with commands, queries, and events. We also have two types of models, where the left one is the command model, because the command handling component persists and reads from it. And the right one is the query model that is updated based on events, forming that synchronization layer CQRS does. And it's also retrieved by query handling components to answer the queries. The idea of these messages can fit in here very nicely. We can have commands coming in from a controller with a result going back to our command handling components, queries going into the query handling components with the query responses going back, and events as a result from command handling flowing out to the event handling components. So we see that we're using messages, using a type of message bus for all of these components, allowing us to stretch the distance between those. Because we don't necessarily know where they reside, the command bus is in charge of that. So if our message bus is in charge of that. So if the message bus can go from one JVM to several JVMs to somewhere in Italy and somewhere in Singapore, that's great. There's one caveat in this design where we need to transition the boundary outside of the scope of using these commands, events, and queries. And that is the controller up top. Because the controller is a means into our system. In an ideal world, everybody would directly talk with commands to our command handling components, but we know there are legacy systems or other applications, or there's just a different API requirement. So we need to have controllers in different formats to be able to translate operations into commands and results going back. Similarly, translate requests into queries and having the response going back. A very logical one is to do a REST controller here, because REST is something virtually every developer knows, I'd say. It's a tool that's been around there for very long. It's likely going to stick around for extremely long as well. And that's fine, because it does a good job. One of the things I don't like about REST, though, is that it doesn't really play nice with the idea of doing these messages and being stretched out and synchronous from one another. If you want to do a REST operation, you need to know the destination you're going to. You need to know the port. You need to comply to a certain ruling. Furthermore, REST in a lot of scenarios anticipates you get the response back directly. A notion of being asynchronous, you can make it work, but it is not what it was built for from the get-go. So, although REST is nice, and it definitely has its merits, and people want to use this and it will be kept using, I'm going to say that this is not the nice road to take if you want to talk with the idea of commands, queries, and events. You might have guessed it. This is where I'm placing RSocket, because I do think that RSocket very well fits with this reactive, asynchronous nature of doing messages from the get-go. So you might say that we're back into sunshine and rainbow land when we're actually going to make a controller based on RSocket. So that's also what I'm going to do in a live coding session in a bit. But first, I have prepared a little bit. So I have a short 101 on RSocket because similarly as the specifics of Secrets, DDD, and event sourcing, I don't have time to focus 100% on what RSocket does. But some of the benefits are that it is basically reactive in nature and message driven, combining itself well with those messages already. It does bidirectional streams, multiplexing over a single connection. It has polyglot support, open source. But importantly, for the idea of the different types of messages I explained, we got several interaction models. We got fire and forget, we got the request response, request stream, and channel. And it's those four that I'm going to focus on. When it comes to fire and forget, you're sending a message and you don't care about the response. You don't even want an okay or a not okay. You're just firing it, which sounds a lot like dispatching an event, for example. Request response is, well, doing something and getting a response back. This would work for queries because we want to have a response. It would also work for some commands if we do want to get the not okay back, for example, or maybe something else like an identifier. We can also do a request stream that we request data and we stream back a set of results. That's nice, so that we can keep up to date. And we got a channel, which is extremely awesome. That's fully bidirectional, that you can send over many changes over it and get responses back as well. With that in mind, we can go to the sample application I've prepared. What I've prepared is a game rental application. So this is an application where you can register, rent, and return games. You can also find them, and you can also, well, see changes occurring on those. And it's this application where I've already defined a bunch of commands and queries, and I'm going to see how these map to the idea of what RSocket does. So I pointed out that this game rental application, it's a basic one, right? But it allows us to do a rent of a game. It allows you to return a game, and it allows you to register new games. If we place that to the interaction models, if we look at channel, we're pretty certain this doesn't really map with channel. A command is going one way to one source. We might get a response, not in all cases. We get an okay or not okay. Just one thing. So channel and request stream don't really fit. Fire and forget and request and response do though. And why also fire and forget? Well, because not in all scenarios do you care about the response of the command handling. Maybe you want the component handling to retry on its own, and the component dispatching just to dispatch it. There are also plenty of scenarios where you do need a response. And a very clear example of this is one caveat when it comes to just sending okay and not okay is that the creation of a command model also returns you the identifier, because you need that to do following operations. So that is one of the requirements of dispatching commands. There is some notion of the okay containing an identifier if it has created an entity or an aggregate. So with that in our back pocket, I'm going to take the assumption that rent or return, we just rent something and return something. That is fine. But registering is placing a new game in our inventory. So we need to have that identifier so we can share that information if somebody needs to rent or return it right away. Okay, so that's the mapping when it comes to the commands. Let's look at our queries and do a similar exercise. The queries we have in our game rental application is finding a single entry or watching the full catalog, retrieving the full catalog. So when it comes to finding, or these queries, we are 100% certain that fire and forget is not going to work because we need something back. The find is getting a single entry. So a request and a response going back should be sufficient. But the full catalog, that might be something that changes over time. We're just finding everything. Maybe we're subscribing ourselves to this. So this is where request stream would fit in. The channel, on the other end, is something we could make work if we have a single channel for several queries with updating a fully fledged UI, for example. But I'm not going to make that work for the game rental app. It doesn't really fit with the query API we have here. So what I'm going to do is have request response, request stream, and channel as options, but I'm ruling out channel for this exact sample and doing a request response for find and a request stream for the full catalog. Then on our pack pocket, I think it's demo time. What I have prepared, hooray, I really enjoy demos mainly. Showing the actual intent of it all is hardly beneficial, I'd say. In this demo, I'm going to use Axon Framework, as you might have guessed, to give me all those building blocks out of the hood. I'm also going to combine this with Spring Boot because that simply greatly simplifies the configuration of your Axon applications. Obviously, RSocket is in there. And because RSocket works pretty well with mono and fluxes from Project Reactor, I'm also going to use Axon's Reactor extension to take benefit of those mono and fluxes. Lastly, as we're going to do messaging that might potentially be distributed, and we're doing event sourcing, which requires an event store, I need to have some infrastructure in place to support all that. Now, I could register my own database for the events, have my own service discovery to find the routes for commands, have a publication means to publish events like Kafka or AMQP. I'm not going to do any of that. I'm going to use a tool we have provided from Exonic called Exonic Cloud, which is all four of those from the cloud out of the box so that you don't have to configure that. So you get an event store, a command bus, a query bus, and an event bus, all distributed just by registering to console.cloud.exonic and attaching your application. So I've already prepared that. And as I'm talking to a Spring user group, I think this is nice. I also got an initializer. So I'm firstly going to show that initializer before I jump into code. And you might have guessed it, this is really a spiel on start.spring.io because, well, it just simplifies construction of applications, right? So in this case, let me enlarge it a little bit to make it a bit more clear. We got the similar set of application metadata where we have defined a game rental app with a name, a simple description attached to it. You see them defining a project in Java 11. We do have some additional things though, because we make some framework specific stuff. We can expect how we connect to an Axon server instance if we do that at all. In my case, I'm going to the cloud, so I've defaulted to cloud. There's also a thing called context, which really comes back from the domain-driven design world, where you have different bounded contexts. So this is a means to attach an application, put it in a bounded context, and automatically connect it to your cloud environment, if you will. We also got a bunch of dependencies, so I already prepared these: Reactor, Spring Data, JPA, RSocket. We can very simply add one with a similar search behavior as you'd be used to. So I can do a Mongo extension or add Lombok, although I don't have to do that. And extremely important, of course, we got dark mode. Who doesn't love that? Now, all fun and jokes aside, I think it's time to move to my integrated developer environment being IntelliJ, because as I pointed out, I already have an application prepared for you. So, application I've prepared is a secret data and event sourcing app around game rental. So I have a lot in place already. For now though, I'm going to focus on introducing this new controller. You can see there is already a REST controller. Like I pointed out, it's here to stay. A lot of people want this. So I already had it in my game rental app because there was this old-fashioned third-party client that really, really wanted to do REST. But now we're going to introduce that RSocket one because that's awesome. So let's actually do that. The game rental RSocket controller. Legs up. I got a class and I got RSocket game controller. I will be doing what I just did more often because that simplifies my development life. I don't need this one, I know. So what I've done is a live template with profiles underneath, and I made this a controller. You can see that this is still a Spring stereotype. So this is something that Spring knows. This is a controller. It doesn't necessarily care at this moment whether it's RSocket or REST. The first thing that we need to make is that this is really that boundary component going from our or RSocket or REST environment into our commands, events, and queries environment that we have with our Axon application. So we need to have a gateway to go from this layer of talking language to another one. So what I'm going to introduce is the reactor command gateway. Call it the command gateway and the final reactor query gateway. So, and add a constructor for both of these because these components give us a simplified means to do mono and fluxes and to form a gateway to go onto the command bus and the query bus. Okay, so we got these in place. We need to implement that API I was talking about. I think I need this. And that API, I can actually give a glance. We got more time now. The original one I didn't. The API is here in a separate package called Core API. This package is shared with whomever is interested in this API. So this is the only bit that is public, actually, when it comes to packaging. You can see that my controller is package private because I don't necessarily want any components outside the controller package to interact with this. They don't need to. I just want RSocket or REST to interact with this. The Core API is different. This is where we have that register, that rent operation, the rent and the return. We also have events telling that the game registered, rented, or returned, define game query, and full game catalog query. If I actually dive into those, you see that they are regular POJOs. There's not that much exciting going on. It's just a bunch of fields, making them private final, just having getters and an equals and a hash code. So in all honesty, I could have done JDK 17 and used records to simplify this. There's one requirement we see. That's that we need to use a target aggregate identifier to tell the framework that this is the field you're going to use to route the message and to find the command model you want to have this command handled on. It does also not see this in events, which are again just POJOs, similarly as the query. Very basic. So it is these queries and these commands that we need to implement in our game rental RSocket controller. I got more up my sleeve. We got an empty, what we're going to do, I'm going to empty register. So you can see I'm using mono. I'm going to return a string because I'm going to return the identifier of the game I'm going to register. I'm going to do a thing called a message mapping. And by doing this message mapping, I'm calling it register, we've essentially told that this controller has a message mapping for this, and that this is going to happen through RSocket as well. That was pretty short, right? No, very exciting, actually. I need to now actually send a command. See that there are two operations. We can do a send or a send all, where send all is publishing a bunch of commands in order and getting a flux back. In this case, we're happy with the results. I'm going to build the command out, which I've also live templated, as you can see, because I'm a lazy bastard. And here we go. Now we got our basic register operation. Straightforward. Do a similar thing for rent and return. I've also live templated. Aha, here. I already assumed that I might have needed this. So let's put that back in, the rent DTO. In this case, I've live templated the entire thing because it's not overly interesting to see me make more of these. It's just that these are fire and forget. And the way we see that these are fire and forget is because the return type is void. We don't get anything as a result, even though the command gateway might send something back. We don't care at this stage. This is the decision we have made for this application. Okay, we got all our commands now. We can go over to the query gateway. So we're going to introduce another one, the find game query handler. Again, a mono, returning a thing called the game. This is the game. This is the response from finding a game. As you can see, just another POJO containing the query response. And we need to do this differently. We need to do query gateway.query. We see that we have a bunch of operations on this thing. And this is actually because there is more to do when it comes to a query gateway, as I pointed out. There is a direct query going to a group. We can scatter a query out to several people and get our responses. We can also subscribe to results, as I pointed out. For this case, we're going for the simple query. So we're going to take this one. We're going to do new find game query. fill the game identifier, and we need to define the response type, which is the game, like so. And we got our basic find operation. We can also do the last one, the watch operation. Again, you see that we're simply just using message mapping, not dictating at all what kind of interaction mode is being used. That's all based on the result types and how you're actually accessing this thing. Because this thing is a flux, now it knows it's a request stream, whereas here it is a mono, so it is a single response, request response. And we just define what that mapping is. So we're going to do a watch on the game catalog. We again need our query, and this time we're going to do a subscription query, many. And we do a new full game catalog query, and we define the result to be string, like so. And that's it. So we got our basic means to talk with our application to enable us to move into an event sourcing environment. So this might be slightly sneaky because the talk says event sourcing with RSocket. Well, yes, I'm combining it. You could do this fully fledged API also with RSocket, but this time I'm doing a transition boundary, really showing how well I think RSocket maps to the idea of doing commands, events, and queries. And that's definitely an important notion to take into account. Let's run the application. I think it's time for that. So I've prepared one that runs all of it, even though I got separate Spring profiles, so I could make it distributed from the get-go. Maybe I can show that if we have time left. And here we have it going. Let's see, the demo gods are nice to me. So it's a bit slower than I expected. This is longer than I want it to be, but it started up. Maybe because I'm sharing screen, who knows? Let's clear this one out. And we're actually going to move to a terminal because we want to dispatch these operations. And the way I'm going to do this is by using RSC. And RSocket, this is essentially RSocket curl. So it's curl for RSocket. So I can do these operations over RSocket wire. Now, the one I'm going to do, of course, is the register one. So what I have here is, I should have another one actually. Yeah, this is the one. So what you see here is I'm doing RSC, so for the RSocket curl. I'm doing it in debug mode so that we can see more. Here I do need to define the interaction mode. So I'm expecting this to be a request operation so that I send something and I get something back. I route this to register, which maps to that message mapping we introduced. And here we can define the data as a JSON, which is, well, as you can see, a game with this identifier, 8668. In this case, it's the game Hades. If you're into video games and you haven't tried this, please start playing this game. It's awesome. And lastly, what is important here is that we're going to do this to my localhost 7000 because this is where the RSocket server runs. So if I run this, that was quick. Ooh, no handler for destination. So the demo gods were nice to me. Let's see what happened, because I do have a register endpoint here. This is sad times. MID, no handler for destination register. This doesn't seem reasonable to me. Let's see what the properties are. And otherwise, I have an ace up my sleeve. Yeah, this is really 7000. Okay. I'm going to do something lazy. Because this application you're looking at, several steps into it actually. I use this form of an application more often just to attach new functionality and show the flow. Right now I was on step 9, the start of this application. Step 8. Step 9 has an actual working implementation. So let's actually remove this beast. We don't need it because it's going to be recreated. So if we go to this variant, and this is the sad bit about doing live coding, right? If you don't prepare it well enough, something might go wrong. I don't see anything different in this class. That's even more exciting. Okay, we still got our properties here. I can move back into big mode. I hope this is still visible to you all. We got our rental controller. So yeah, okay, let's try this again, right? Let's see if it is going to be friendly this time around. Otherwise, we have a relatively a bit shorter demo than I want it to be. Starting up. So it started up again. Got a netty, and we got the RSocket one at 7,000, so that seems to work. Coordinator claim 16 seconds. Yeah, expecting that too. We registered our command handlers. Oh, that's 0. That's not true. Yeah, that's workable. Queries. Okay, you see a lot of things going by, and I just want to make certain everything's okay this time around. So I'm also going to move to the dashboard that we have with cloud. So up here, I've opened up Exonic Cloud. You can see I got my connected application, game rental application UI with RSocket as a profile in there as well. Well, we got our command handlers and our query handlers. We got a projector for this thing. So it is doing something. Let's see if there are events in the way. No, there are no events. That's true because we have an empty application. So now let's see if it works this time around. So no, like that. No, one item. I got these steps prepared, so I'm going to try it through this way. So we see our socket curl, debug, request, route, register, data, game identifier. All right, now it worked. I'm very happy it did. I was sweating a little bit just now. I hope you didn't notice. Let's go back to the point I wanted to cross. So we've done our operation. We've routed our register operation. We see some logging information from our socket. We see metadata flowing by, actually. We see the register operation go. We see the data flowing here as well. We see it even in bytes, if we will, in hexadecimal format. Is it? Yeah, hexadecimal. And we also got a response back. So we get the receiving thing, as you can see. And we get 8668. In all honesty, we already shared that as the identifier. But as I pointed out, when we are creating an entity with Axon Framework, you always get the identifier going back in. So we get that response, signaling that the request response operation worked. Thank God. So we can go about to actually renting something. So here I have socket operation to rent. You see it's again RSC debug, but this time I'm defining the service mode differently. I'm doing a fire and forget, routing it to rent, and the data is different. So I'm expecting somebody to rent out 868. That somebody is Ben Wilcock, a good friend of mine. He's going to have a hell of a lot of fun with this game. I know that for sure. If we rent that was extremely quick actually. We see the operation going and the data flowing. We don't get a response because it's fire and forget. I think it's time looking at our terminal because I would expect this to work, right? We also want this application to do things. And luckily, what I set up was a thing called a logging interceptor that will intercept every message and log everything. So we see a register game command is being dispatched. We see it's also coming in because this one application is dispatching with the controller and handling. In turn, we also see dispatching a game registered event, which is also handled by something with a response going back. So the register worked. Similarly for a rent, we got a rent game command going in and a rent game rented event going out with successful handling. So it seems I have prayed well enough to the demo gods this time around. So let's actually also return something. So Ben Wilcock is done with Hades. I can't imagine why, but he wants to return it. Maybe he wants to rent something else. So if we do this again, just fire and forget immediately with the same setup. Nothing exciting. And we do see return and game returned event flowing through. Nice. Let's actually start defined operations. So this is just a different beast. And in this case, we're not using JSON, as you see, because we just have a single identifier, a single string. We also saw that if we go back to our controller and we open up the defined operation, we just get a single game instead of a DTO. This also signals that these DTOs, as long as they are serializable or deserializable through JSON, will automatically be picked up, simplifying your life. Amazing tool, if you ask me. If we're going to find, I expect the Hades game to be returned with a lot of data, namely in this JSON format, which is hard to read at the moment. This is better. We got Hades, we got the release date in here, as you can see, description of it, and whether it's single player or multiplayer. All right, now let's do the last one, which is the watch. So we're gonna do catalog, I think. Yeah, catalog is what it's called. We see that this, again, you see the pattern. We need to define a different interaction mode. This time we're doing request stream, which is done by -- stream towards the catalog. We don't provide any data because there is none. We just wanted to stream everything. If we hit this, it stays open, as you can see, because we're reactively waiting for new stuff to come in. So what we can do is we can push this to the left, and we open another one on the right up here. And I'm going to register another game. And the game I'm going to register is Horizon Forbidden West. And, well, because that's also a nice game. When I did this previously, this wasn't been released, but we all know it's already been February this year. So, yeah, this also worked. We saw that this did its thing. We see the response coming back. But we also see that the watch now returned to Horizon Forbidden West. In the middle, we see some keep alive messages because it wants to keep the connection alive. Okay. So that was, in all honesty, the basic showcase of why I think RSocket works very well. Granted, we still have time. I see I'm on 43 minutes. That's, well, I'm definitely taking more leisure time. I had to with the problems. But I think it's also fair to actually show something about the internals, actually show stuff. Because what I have now shown is just the controller and the core API, the messages. You can give a quick glance for the REST controller. You can see it's roughly similar. We're also using reactor gateways and doing these operations. Now it's just post and get mappings, adhering to the requirements you'd have from a command, not returning anything, even though that might be different from what a lot of UIs with REST expect. We still need to comply to this because a command doesn't return anything. You could make it so, but it's not, you shouldn't do that. It breaks your flexibility. So next to the controllers, the more important bits are the command and query packages. These resemble the command side and the query side of our application, where the game is the heavyweight of it right now. This is a command model in the aggregate sense of it. So it is a group of associated objects, in this case, a game with some renters inside it. There's a release date and stock and a game identifier, where the game identifier is the aggregate identifier. We need to tell it it's the aggregate identifier. And we're using an annotation up top called @aggregate, which is our own Spring stereotype, which tells Axon's Spring Boot auto wiring that this class needs a repository, needs to have a factory, needs to handle commands, needs to receive events for event sourcing. You don't have to configure that just by using this annotation. This is also where you got a bunch of command handlers where we make our decisions. And if we have made a decision and we're happy with it, we apply an event within the lifecycle of the aggregate, as you can see here from the static invocation. From a register game, we don't make any decisions. We simply apply an event. But you can see that rent has some repercussions. We can't rent out a game if there's not sufficient stock or if the release date hasn't been met yet. So we throw exceptions as results in those cases, which is perfectly fine. This is a not okay from the perspective of command routing, of talking with that idea of commands. Similarly, return as that as well, where we expect the same person to return the game. This is also where event sourcing handlers reside. So this is where we update the state of a command model by sourcing it based on its own events. The way to tell the framework that something is an event sourcing handler is by using the @event sourcing handler annotation, so that when it is retrieving that model from the event store, recreating it by handling all the events, it will invoke the event sourcing handler annotated methods to adjust the state. This gives a nice separation between decision making and state changes. The query side is different, as you might expect it. In this scenario, I've chosen to use a game view being a simple entity. You can again see, as you might have spotted with the aggregate, that this is package private, just as the controllers. because we don't want anybody else to access this component. It is from the query package, from the query side. We're doing a well-structured modulith in this case. We're making packages, they could have been modules, and we're ensuring nobody can access those so that we can be breaking it apart into microservices as we see fit, which I've been doing with profiles in this case. This game view is backed by a JPA repository, pretty straightforward, and we got a projector projecting the events into that repository. So again, we have a profile, it's just a Spring component, and we got some Axon magic in here to add additional configuration. Here we have regular event handlers instead of event sourcing handlers, because when it comes to projecting state in such a projector, you're streaming the events. This is not sourcing. The command model is sourcing itself. That is what event sourcing is, recreating yourself based on your own events. If you're just handling events, you can decide the order, how you see fit. You can decide which set of events you want to get. You can decide how you act if that's not something you're happy with at that moment in time. It's a completely different beast, requiring a different annotation. On a game registered event, we not only store the new game view, we also emit the update of a new title to the full game catalog query, essentially showing how I made that flux of titles coming back in with the watch operation I did, or the request stream operation I did through RSocket. We also got a game rented and returned, which is finding an entry, updating it by incrementing or decrementing, throwing an exception if it's not there. And it's this component that is projecting the events into a model that is also returning the model. So even though in our earlier diagram, we had event handling components and query handling components as separate things, which they can be, there are plenty of scenarios that those reside with one another. Because an event handling component likely projects events into a query model, and the one answering those queries, why not make that the component in charge of updating it? Seems very reasonable as well from the perspective of emitting these updates. So this is where our find game query and full game catalog query come in, where we find something in a repository, map the game view into a game response, because we don't expose our game view. It's package private, remember? We expose the game because that is part of our core API, and throw an exception if it's not there. When it comes to the full game catalog query, the initial result is getting the entire set. So that's been me talking a shit ton, and I have a last thing in mind I want to show. This is going back actually to the dashboard. I already showed this a little bit because I just had to with the debugging. Here we see the command handlers that are registered, the query handlers that are registered. For the key 9, you see the game catalog name coming back. This is also something I had open up here, game catalog. By using the processing group annotation, I can tell Axon Framework that this component belongs to that processor, that consumer of events, so to say. We can see configuration of this. So we see that this was apparently streaming events, and it is in 16 threads and segments. So we didn't notice that. We could just change that on the fly. If we open the event store, we can find for the game rental application. If we just click search, we get the 4 events we have. We can eliminate some data we don't need. So I don't really need the timestamp. The payload revision is not being used. All the events come from a game aggregate, so that's fair. We see sequencing ordering in place, so I think that makes sense. And we got the aggregate identifier. You see that we got 2 different sequences. We got a sequence per aggregate, and we got a global sequence, because you want to event source based on the events from a specific aggregate, so find them based on an identifier. And if you're streaming your events, like with the consumer, we want to start at the specific partition or position. So for simplicity, I'm leaving them out so we can see a bit more from this. We see that the payload type is the fully qualified class name. We also see that the payload data is being stored here. And then we got our metadata as well up here with correlation and trace IDs out of the box. All right. All niceties put aside, I think it is a fair moment to stop. I think I've got one remaining slide. Oh, this one should have been hidden, but it is what it is. I'd like to thank you all for being here. And this is actually, I would like to see shared with the rest. So, Giorgio, if I could share these links with you.
Yeah, sure.
Because can I drop them in the chat, or should I do them in the private chat?
I'm private chat, and then I post the
There you
links.
go. So the top link of these two, that is the project we've just been looking at. Like I explained, it got several steps. It has a README in there as well, so that you can go through it. You can quickly give a glance of the README for those that are interested. It gives a description of what this is, of what the intention is, and you can move through all the steps. All the steps are described so that you can get a feeling for what's happening in that moment in time, and it's explained how it's run. There are also unit tests in there if you want to test it through testing, just through that approach. The operations I used are here as well. Yeah, a lot of info. I hope
Yeah.
this is beneficial.
Thanks for the great talk. And we have
Thank you.
one question.
Sure thing.
Okay. The question is it okay to use CQRS only for a small part of our application and not for the whole domain?
Yes, I think so, Marco. I think that's a very fair question to ask as well. How I'm portraying it right now is that we're doing it overall. And that's a choice, right? You don't have to do this. It makes sense for some applications. It might not make sense for a lot of those. Definitely back in the day when, so Axon Framework has been around for 12 years now, as I pointed it out. Back at the start, we saw that the majority of users were people that were very heavy on their domain. So in aggregate, as I have it up here, this would be too small. This would be overdoing it. For the sake of a sample, this is fair, but this wasn't really the benefit they gained. As soon as Axon Framework became more interesting was the moment that microservices became hip. And the pure reason for that is messaging. Hence why I'm taking the messaging ordering. It is that idea of doing commands, events, and queries that's going to help. But doing commands, events, and queries, you don't need to do CQRS entirely for that. This is how Framework is set up as well. You can just depend on the messaging module, just getting the logic about dispatching commands, dispatching events, and dispatching queries, and that's it. You don't need to do modeling. You don't need to have command and query models. You don't need to do event sourcing. If you want to, the Spring Boot starter gives it all to you, and it will not use it if it's not being used. But yeah, that's a fair philosophy. That's reasonable.
Thanks.
Sure thing.
Okay. We don't have any other question. So
Okay.
really thanks for the great talk. It was really interesting. And I hope all of you enjoy this event. If you want, click to the subscribe button of YouTube to receive notifications of new Italian coders video. And thanks for watching. And thanks to you, Steven. See
Sure thing,
ya.
Giorgio. This was awesome.
Cheers.
Goodbye,
Bye.
everybody.
Bye bye.